Okay. So, example 1. Basically what we're going to do here is we're going to do like, I was thinking we would do maybe 2 problems. Where we're talking about an examples of story problems, and I'm going to let you work. Okay, so the first one, let's say, how long do you guys think that people on average keep their cell phones before buying a new one?
2-3 years.
On average, it's actually a year and a half. Okay? Now, the hard thing to imagine is that we live in an area where we're not getting brand new things every single, few months, but we have to average out with some other areas, right? So for every person who keeps their cell phone for like 5 years, there's somebody who gets a new cell phone every 2 months. Okay? Which is, both are probably hard to imagine. But, all right, so I'm going to write down mu equals 1.5. Do you guys remember what mu is? The average. All right, so the average is 1.5 years to keep your cell phones. And the standard deviation, do you remember what this is called? Sigma is 0.25 years. That means on average, most people are between 1.25 years and 1.75 years, closer to 2 years. All right, so now we're going to answer the actual story problem question. It says, find the probability that a person keeps their phone less than 1 year. And the problem says that this is a normal distribution. All right, now what does normal mean? A bell curve. It specifically means a bell curve, okay? Normal does not mean like what it means in every other situation where we're like, yeah, you know, what we expect to have happen. In normal and statistics specifically means a bell curve. All right. I'm still putting 0 in the middle. I'm not putting 1.5 in the middle because this is a graph of z-scores, not of the actual data. So the first thing we have to do is to find a z-score first. Do you guys remember the formula? X minus mu over sigma is a z-score. Nice job. X is the data point that you're interested in. Mu is the mean, and sigma is the standard deviation. So what's the data point that we're interested in? 1 year. We're kind of like talking about just the line, and then we can decide if it's shading to the left or shading to the right, depending on the left then or the right or the greater than. So this is a 1, and that's from this. Minus mu is 1.5 divided by 0.25. Go ahead and you can put this in your calculator or you can do this in your head. Look up first. Look up. The top has to be in parentheses for you to do this right. What'd you get? If you do it right, you should get -2. So if you're putting it in your calculator right now, I'm going to give you a second to make sure you get it right. If you didn't get it right, turn to your partner and see what you typed in wrong, or ask me. Get it right, Carter?
Yeah.
Okay. Where's -2 on here? Where is it? 2 steps, yeah, maybe like about here. There's about -2. We're just drawing a picture, right? All right, and we want it less than 1 year, so where should I shade? Yep, I'm going to shade to the left. And now we've turned it into a problem just like yesterday. where all we have to do is look it up on the table. And do you remember it shades to the left, or the table always goes to the left? So look up -2, -2 point what? -2.0, so look up with your partner right now. Michaela, make sure you show Alex what he's doing. -2.00 0.0228, and that is the probability that somebody keeps their cell phone less than 1 year. We've got a 2% chance. Okay, does my picture look like I shaded 2%? No, it looks like more than 2%, right? Okay, so who's wrong? My picture's wrong, right? Like, I just sketched it. Everybody understand that? The biggest thing when you're doing this is if you sketch a picture like this and then you accidentally get something like 97%, you should look at this and go, well, okay, well, clearly 97% isn't right. I know it's less than 50%. I know it's going to be a small number, right? And then you realize, ooh, I accidentally did 1 minus. I shouldn't have done that. Or maybe I looked up on the wrong side and I did that wrong. So the picture does help. All right, we're going to try one more, example 2. And this one you're going to try with your partner. All right, example 2 says, how long do you think the average person spends in a supermarket when they're shopping for groceries?
An hour.
Close.
1:15.
45 minutes on average, remember. Okay, there are some of us, like me, who hate the grocery store and go to the grocery store like once every 3 weeks or 2 weeks, and then I'm there for like an hour and a half because I have nothing in my house, right? And it sucks. And then there are people like my husband who go to the grocery store and come back with 1 gallon of milk because he needed milk. And I'm like, we don't have toilet paper. And he's like, well, I got the milk we needed. And I'm like, cool, maybe. All right. Anyway, that's my own problems. Okay. So they have a standard deviation of 12 minutes in the store. And this is a normal distribution. I can't spell normal. And I want to know what's the probability that a shopper would spend between 24 and 54 minutes. Find the probability. That a shopper would spend between 24 and 54 minutes in the grocery store. Okay, I'm going to draw a picture. All right, so explain to me what you think we should do for our plan. Triton.
Shouldn't we mark where 24 and 54 minutes would be?
Okay, well, we know the middle is 45 minutes, right? The average is 45 minutes. So maybe like 24 is like over here or something. 54 is probably closer, maybe like that. There's 54. We want between this, right? But are our z-scores 24 and 54? No, what do we have to do?
We
Yeah?
just mark-
Right. So you're going to do x minus mu over sigma twice. One with 24, one with 54. Get 2 z-scores. And then you're going to find the area between them by looking up the bigger one and the smaller one and subtracting the 2. Okay? Do this with your partner.